A 50 kg bucket is being lifted by a rope. The rope will not break if the tension is 525 newtons or less. The bucket is started at rest, and after being lifted 3 meters, it is moving at 3 meters per second. If the acceleration is constant, is the rope in danger of breaking? Okay. Here, what is happening? The 50 kg bucket is being lifted by a rope. So what are the forces acting on it? The tension force acting upwards and then gravity acting downwards. That is represented here. And again, I will represent with this one, free body diagram. Okay. So the G acts vertically downwards. And then the tension acts vertically upwards. And then obviously acceleration is the body is accelerating upwards. Now we have to find out the tension in the rope. That is the question. This is F tension. And then this is Fg. And then data. What is the data? Mass is given as 50 kilograms. And then Vi, initial velocity of the object is 0 because the bucket starts at rest. And then distance moved is equal to 3 meters. And the final velocity, it is after reaching 3 meters, it is moving with a constant velocity of 3 meters per second. And then acceleration is not known to us. Now, what is the force equation? Sigma Fy is equal to, it is in the y direction. Fy is equal to F tension minus Fg is equal to Ma. We know Fg is equal to Mg. Okay. Therefore, F tension is equal to Mg plus Ma. And acceleration is not known to us. We have to find out the acceleration. How to find the acceleration? Using the kinematic equation. What is the kinematic equation? Vf square is equal to Vi square plus 2Ad. Okay. So here acceleration is equal to Vf square minus Vi square over 2D. So this gives 3 meters per second square. 3 meters per second whole square minus 0 divided by 2 into 3. So this is 1.5 meters per second square is the acceleration, upward acceleration. Now Ft is equal to mass of the object is 50 plus G plus A. G is 9.8 plus 1.5. So this gives Ft is equal to 565 newtons. And then 565 newtons is greater than 525 newtons. Therefore, the bucket is, the rope is in danger of breaking. Therefore, the rope is in danger of breaking. This is the answer for this question. Thank you. Bye-bye.